Thanks very, very much for coming. I hope you are obviously enjoying the conference. Had a good keynote yesterday, enjoying Chicago. What we're going to talk about today is how we at x.ai build safe or safer and more testable Scala production systems in a pretty interesting environment. So yeah, hello from me. I'm Andrew. It's Varun, my colleague. Don't forget the voting thing. Obviously, that's mandatory. There's only one button on the vote, so great. That's our version. So the short one, like I'm the head of duct tape. I mean, basically I do infrastructure stuff and stuff throughout the stack because we're a small team relatively, and there's always more problems than there are people to throw at them. So that's kind of my role, and Varun is our backend wizard.
Hey, I'm a backend guy, so I generally, if you come and talk to me about servers, I start getting excited and I talk a lot. So that's what I do at x.ai. I do a lot of Scala, Python, Node.js, and stuff. So that's what a quick note about what we do, actually. So what we are x.ai. We are building an artificial intelligence assistant, which does one thing and just one thing, which is to schedule meetings for you magically. And we are very focused on this idea that we want to do only that. So any feature that we build, any bug fix that we do is all towards the idea of scheduling meetings. So how it works is you simply send an email saying, hey, can you schedule a meeting between me and Andrew? And Amy takes care of the rest of the ping pong. She understands the email. She sends out an email to Andrew and figures out what time works for them and understands Andrew's reply, and then finally sends out an invite. So that's what we do. We have been doing this for about 3 years or so. And one thing you've learned is that it's very, very, very challenging. It's more challenging than we thought it would be initially. And yeah, so there are a lot of interesting properties of our team, actually. So for example, we have a lot of diverse systems, you can say. So some of the systems are machine learning. Some of the systems are deterministic and very complex deterministic logic. And within our team, we have a diverse set of skill sets. So some people are Scala wizards. Other people are extremely good at Node.js. Some people are extremely good at testing. Others in deep learning and machine learning and so on. And finally, there are diverse experience levels where we have people with like 14 years of experience, and we have some people with who are just out of college. So one of the things is that, so given that there is a diverse level of experience, we do want to implement the minimum set of, or just propose the minimum set of things that we want to do, like the safety nets that we want to introduce into our systems, specifically our Scala systems, so that we can get the basic amount of safety for very little cost.
Yeah, I think that I was joking earlier about the meeting scheduling and the about the video conferencing and the projectors. Meeting scheduling is the third thing that we're still not going to get totally right by the year 3000, but we're trying. What I think is important about our environment is it's quite representative of a lot of people I've spoken to in what they're doing. Whether you're trying to onboard new teams, whether those teams come from different language paradigms, or now, in our situation, we have a bunch of people, heavily functional, influenced, very, very advanced, if you like, from a sort of computer science perspective. But a lot of people who know Scala essentially is a DSL into Spark. And Scala as a language that is very flexible and not very opinionated has this enormous space of possible things you can do with it. And so I think this is a challenge for this language that is maybe more prevalent than in other environments, that you really have to figure out how to take this enormous spectrum of possibilities and kind of boil it down. That's the kind of thing I was taking too long to say. All right, so the agenda, what are we going to talk about? What we've done in terms of coding patterns and guidelines and then tools, architecture, to try to achieve this goal of having a system where as many people as possible in our limited team can work on all parts of our code base and do so safely without blowing things up and waking us all up at 3 in the morning because we all get the pager. And then if we manage to get through this in time, we'll have a little bit of a Q&A. So coding patterns, there's no, let's just go on to the next slide. What do we got? There's 3 main things I want to touch on, with a big credit to Chris, who's sitting back in the room because he was responsible for a lot of this stuff. This is not going to be rocket science. I think one of the main TLDRs for me, and we'll come back and touch on that a little bit later, is that these are parts of the language that you will use all the time, like relatively simple things, like equality and so on, string operations. You might think, yeah, but why would we invest in trying to make those safer? I think the key lesson is because you do them all the time, right? Almost every piece of code you write will do checking is A equals B somewhere in some shape or form. And yes, the language has operations for that, but if they're not as ideal as you need them to be in your situation, don't be afraid to specifically tune even those parts of the language. Because yes, they're very common in the language, they seem very basic, But if they happen everywhere, that's where you will get a lot of mistakes. So I think that's the sort of meta level lesson is that don't just look at the weird, funky parts where you have to do something very specific for your business problem. Look at parts of your code base that you use a lot and figure out how you can make those better and easier to use for your team. Okay, so the first one is a kind of obvious one that we all know about. It's the sort of apple equals oranges problem, right? You can write this in Scala and, well, you'll get false back. And if you're comparing fruits, that's fine. So it's sort of more domain-specific version of our problem. We deal in meetings. So what are the kind of things that exist in our domain? You have emails, you have people, you have meetings, you have locations, and so on. And you get lots of code that looks a little bit like this. Very simple stuff, nothing fancy here. And you can write this, and it returns false. And probably when you wrote it, you didn't expect it to return false. And the reason is, well, it's not actually what you were trying to write. But it's possible to write it, and that's exactly where the problem comes from. This is the problem. It's not meant to be puzzling. Like I see heads nodding. There's nothing really special about this. But clearly, and you know, why is this even possible? Like, why does this work? Why does the language allow you to do this? Well, because in a sort of general sense, this is not type safe. In a general sense, you're supposed to be able to compare anything with anything else. It's a type system based on inheritance. If you were Martin back in the day or anyone else, if you were to design an equality operator for a language that has overridable equality definitions, of course you have to define the built-in equals operator like this, because you don't know a priori what's going to be equal. But in a domain-specific context, you know much more about what things you really want to compare or you should be comparing with each other. So what you would really like is you would like a statement such as Andrew equals guess.find not to compile, because you're trying to do something that is really not what you intended to do. This is not I'm not making some kind of revolutionary claim here. This is something that a lot of languages already have and support natively out of the box, and even Scala has a few variants of this. But the solution we came up with for this is, no, make a new operator, triple equals. Scala's, one of the things that's very nice about it is it makes it very easy to define new syntax that looks natural, like not like Java where you end up with these weird dot equals, my equals, something like that patterns, but you can really quite easily make these new operators in the language. And so here you'll get what I think you want, or at least what we want in this particular case, that you actually, the compiler tells you you're probably not doing what you wanted to do. And how we did this. So one way you can do this if you're opening up the Pandora's box that is Scala Z, you can do this already. You can use type classes. There's a type class-based approach to define equality like this. That'll give you a triple equals. Chris can tell you, I think, more about exactly why we didn't do this all over the place. But this is type safe, but it requires some boilerplate in general. Like if you use shapeless, some of that boilerplate goes away, but you have to write this stuff. You have to sort of be more explicit about which things you want to be equal. In our case, we're quite happy with the basic equals. We just want to have some more type safety around it. So one thing you can do, nothing too fancy, nothing complicated. You declare something called safe equals, and then you wrap it in any vals and stuff like that, or if necessary to make it sort of performant. We'll talk about that a bit later. But you just define this operator on there, and that's where you link the type. So you have the type T at the top, and then the type T in the definition of the right-hand side argument, and that is what means that when you try to write Andrew equals, blah, 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 that you'll get this type error. So it's not totally foolproof in the sense that you can still do this, right? I mean, you can force the type T to be any, and then you still get the basic ability to compare any two types with each other, but this looks smelly. And I think that's probably the best that you can hope for. Like, if you see a line in your code that looks a little bit like the bottom line, we're not making it impossible, but it's much clearer from looking at this line of code that this is probably not what you want to be doing. And as I said, going back to how common equality is, this is a really big gain. You know, it's inference safe, I guess, if you would put it that way. It's not necessarily fully type safe, because you can still do stuff. Similar problem. I'm going to go through this one a little bit quicker because I can see I'm kind of getting a little late on the time. Containment. Equality, something you do all the time. Containment, also something you do all the time. You get something like this. You make a list of guests, and you try to check whether the ID of a particular user is in there, and yeah, it's not in there. But here, you're fundamentally expressing, it's not really what you were trying to check for. You know, when you were writing this, you probably thought that this was going to work, there's just some confusion about what the type of the list actually is, what kind of elements are in the list. And again, if you're in a domain-specific world like we are, where a guest and a guest ID obviously are not the same things, then you don't want this to compile. Like, you want to be told, you know, why are you trying to check for a guest ID in a list that doesn't contain guest IDs? And as I said, in our case, when you have people working on your code who, it's not like they've written all that code, they're coming at a particular method to fix a particular problem, and they may not have seen that method very much, then this is the kind of thing you want them not to be able to write.
So I just want to add another note to this. So this is not like a theoretical problem. This was a real problem that we faced in like 1 or 2 years, 1.5 years ago. We had this thing, and it actually compiled. It got shipped to production, and we just started spamming people. Emails after emails after emails. Like, we spammed like 300 emails in a span of 1 hour, something really crazy. And when we realized that only when somebody complained to us and said, why are you sending me so many emails? And that's when we decided, okay, fine, we need to make it safer.
Oh, yes, in general, none of this is theoretical, right? This is all stuff that, it's all like the result of wounds, if you like put it that way. And so the whole purpose of this talk is like how to avoid you having to suffer through the same kind of thing. So why does this work? Well, because you have covariance in this case. You know, a sequence of tiger is also a sequence of animal. You want to be able to do that. Makes sense as a design decision in a language that allows inheritance of types. But what it also means is that since you can assign a list of guests to a list of any, I can write val g2 list of any equals that list of guests, contains also has to be able to accept any particular type of argument, because I can treat it as a list of any. So again, it makes total sense from the basic design decision. There's no other way to do this if you want to support kind of inheritance hierarchies of compound structures like lists, but not what we want in our particular case. What we really want is to be the compiler saying, you know, you're trying to look for a guest ID in a list of guests. That's clearly not what you want to do. This doesn't compile. And so enter safe contains. Similar kind of implementation. It does what you expect, has the same kind of caveat in the sense that you can still force it to do the kind of weird type comparison, but again, it looks weird. And I think that's something that's sort of the best we can hope for. And I mean, looks weird is a vague statement. You can make it more precise by having linting rules that prevent this kind of stuff, or at least flag it, right? So you get what you want here. Okay, moving on. Safe primitives. How are we doing for time? A little bit more time. So another one, so this touches a little bit fortuitously on what Martin was talking about yesterday in terms of implicits and the danger of adding implicits to base types. Base types are risky, right? If everything's a string, then, you know, strings can magically turn into other strings. Strings can be added to each other. If your email ID is a string and your guest ID is a string, then you can look for email IDs in a list of guests and so on, or guest IDs and so on. Long story short, one of the lessons we've learned, don't do that. Even if the thing is underlying, you know, you're not actually trying to restrict the string type, you're not like trying to have pos int or something like that. I think Bill will have a talk that will touch on some of that stuff. Even if it's really, you want the whole space of a string, don't just use a type alias, actually wrap it in a type. Because then you can get some kind of interesting properties of safety. Yeah, safety? Type safety. You can't write guests find by ID of an email ID. You can't do the second kind of thing. And you can do it in a way that actually isn't very impactful on performance. And there's a few things that we'll talk about a little bit later that you should add to make this easier. So when to use type wrappers, you know, when the possible values, it's not an enum, like there's too many to usefully use in an enum, or there's too many, or it's really a genuinely infinite unknowable set. And also when you want to make sure that you use this new type information to prevent things like comparisons from happening. Like two strings can always be compared, it's difficult to tell them apart. A guest ID and an email ID, get the compiler to help you prevent mixing those up. And then maybe a bullet point that I guess I could have added, this also makes the scope or applicability of any implicits that you define much more narrow. Because suddenly when you convert, like, I don't know, if you were to convert a guest ID to an email, whatever, as an implicit, if that's string to email as a type, much, much, much bigger problem than if it's guest ID to email. So this magically helps you avoid the danger of having very broadly applicable implicits as well. So I think I'll skip this. Safe matching on sealed structures. Interesting. Come talk to me later. But another one. Very, very common. This is the kind of stuff, yeah, we work with emails. Like, it's all text, right? So at some point or another, we have to do this kind of stuff. And yes, this is the kind of stuff that happens. Varun, do you have a nice anecdote? I don't know where this exactly...
This is exactly what happened, where we sent out, hey, hi, some of Andrew. There was actually one case where we sent, hi, none. How are you doing? So,
I was about to say, that's when you feel really bad. Like, if you're some of me, that's okay, but if you're none, does not feel very good. Right. Yeah. So what's the problem? The problem, again, is that because, the problem is that you can write this kind of stuff, but if you put option string in there as opposed to a string, you don't get any hint that you're doing something you don't want to do, because anything can be treated as a string, and S allows any arguments, like string context. So that's maybe it's not quite so well-known fact. S is the most common string context, but there are actually others, even native ones, raw, for instance. And they're actually very easy to define yourself. So you can do some pretty interesting things with additional string context. It's not too complicated. But the problem is that the basic one that we like using all the time just accepts anything, because you can turn anything into a string. What we want is something different. So we created our own called safe. And you can choose whatever you want, and it will give you this kind of compilation error. And the way to do that, obviously, is you, instead of saying, I will accept anything and then call toString on it, I will accept a more limited set of types that I consider safe to turn into a string. So you do something like this, and then you expect strings here. And if they're not already strings, then you have to figure out how you can turn them into strings. There's a similar problem with plus. You can look at the code, by the way, for the implementation details. It's not secret. There's a similar problem with plus, obviously. You can do this kind of stuff. There's a very funky version of this. Like, you can try, I skipped one slide here. You can try plus plus, as in set, or rather seek kind of concatenation. That works for some cases, but still is interestingly quirky. Long story short, there's an easy way to make this safe as well. So you start to get, you write this kind of stuff, and you get an error, because it's not one of the ones that you've defined as being safe to concatenate together. And there you go, safety for that kind of stuff. All right, let me just check. Yes, so all this wonderful code is in a highly versioned library that's out there on the web. Go check it out. It's, take some of the implementation, take the library, contribute to it, suggest new things. Very useful stuff, helps us a lot. Over to you, Varun.
Cool. Thanks, Andrew. So how do we deploy safely? So on a high level, this is what our architecture looks like. We are basically an email in and email out system. We take in emails, and we have a portion of a system which does all the machine learning, tries to understand what are the times, what are the locations, what are the intents present in that meeting. This is where all the machine learning, the deep learning stuff happens. And then once we figure out the deep learning and the machine learning stuff and extracted times, locations, and intents, we then pass it to the decision-making system, which basically figures out, OK, fine, now that I know what has been said, what should we send? What time should we propose to this other person? Or what is the location for this meeting? Or should we send the invite? Who should we send the invite to? So that is the decision-making system. For the rest of this presentation, we are going to be zooming in on the decision-making system, although the machine learning system has its own set of challenges. But that's not what I'm going to be talking about here. So how do we test this decision-making system, right? So what does it mean to be testable? Like to be easily testable. So test should be easy to write. It needs to be fast. And when I say fast, it needs to be fast to execute, but also it needs to be fast to add another test. And of course, it should be reproducible. So in our particular domain model, right, the input can be very, very complex. So you're not just writing tests on a single email, but you're writing tests on the whole thread of email. And a single email within this whole thread can contain, actually specifically has 36 fields. So if you have a thread of, say, 10 emails, and if you have to set the parameters of 36 emails or a subset or a huge number of those 36 fields in those emails, you can imagine that your test can easily, a single test can easily be like hundreds of lines long. And that's kind of where we started off with. But over time, we have improved the testing, the test data generation, the test library that we have. So our take on this is we use default values in our test data and our test fixtures. But in production, we don't use default values. Because yeah, you don't want to accidentally initialize incorrect default values in production, but they are very, very useful for tests. And on top of this, we have built some small DSLs, and I use DSLs in quotes, but small functionality to make it very, very easy to write tests. So practically speaking, this is what it looks like. See, on the left side, you have the case class, which is used in production, which has lots of fields, no default values. And on the right side, you have this object email, which is sort of the companion object, which looks exactly like the email case class in production when you actually use it, but it has default values. And within the apply method, you can choose to sort of convert the default values of these functions into something that fits into the case class of this email. So when you actually use this and write a test and write a thread, which is this is what a thread looks like in our test fixtures, you get this really, really concise but also easily understandable sort of test fixtures that you can just write. So with this, we have sort of scaled from few hundreds of tests to several thousands over a span of like 1.5 years. So this has been very, very useful to just write tests and things. So that kind of sort of comes down to the foundations, right? So when you write a feature, right, and you look at the test and you say, hey, it's so boring to write a test, or it's so painful to write a test, you'll probably write one or two tests just to tell everybody, hey, I wrote these tests, and the test passed, and I can deploy it. But if you make your DSL and the test data generation very simple, right, then you're going to write many, many more tests for every single feature that you write. So this is something we have found very useful over the last 1.5 years.
Just one thing to quickly say. This goes down into specifics, like investing in slight usability things that you might think are not really worth it. Like if you look at the example here, the second email, it says 2 equals guest. If you remember the case class, the actual production case class, 2 is a list because you can send an email to many people. So you might have said, yeah, why am I going to bother with this convenience thing? I'll just make people pass a list. I can tell you, once you've written 1,000 tests where you write a singleton list, it starts to get annoying. It starts to get less readable. So yes, invest the effort in allowing people to pass a single value or a list in whichever case they need. Mm-hmm. And so, yeah, you might think wasted effort, but given that you are going to use your test fixture constructors all the time, all over the place, it's worth investing effort into making them as clean and readable as they possibly can be.
Yeah. And on another note, you always have to make an escape patch available, because while this is beautiful, this is concise, it will not account for all the tests. So, but in this case, with this pattern, all you have to do is just import the models case class and just use that directly. It rarely happens, but when you need it, it's there. Sort of a bigger picture on like testing like feature implementations, right? So on one side, you have like the changes that you're making a change. You know that this change should have this behavior, and you know that this change should not have this behavior. And this is sort of easily testable with just unit tests, integration tests, or anything in between, right? But on the other side, like you make a change, but it has all these other effects that you could not have thought of, like especially, and this is especially true if you've written like big software, right? All these downstream changes where you could not have thought of, and only when you deploy it, then you realize, oh shit, I should have thought of that. But that's hindsight. I don't think there's a general solution or a widely accepted solution for this as a software development, but I'm going to be talking shortly about what we have done to make this a little better. That's it. Taking a slight detour, debugging, right? So sometimes we make mistakes. Like for example, we get complaints from our customer success team saying that, why did Amy send an invite for 1 in the morning? That does not make any sense whatsoever. And this happens sometimes, and quite a lot actually. But the thing is, what we should try and do is we should make it easy to fix it, right? We need to make it easy to reproduce and fix it so that we get rid of problems as soon as possible.
Just to be clear, not the 1 a.m. invites, but there's lots of cases where we want to understand what's going on.
Yeah. So from the architecture, right, this is of the decision-making system. This is the high-level architecture where you have an HTTP request, an I/O call. This I/O call is basically, it fetches all kinds of data. This may make calls to microservices. This may make calls to databases and other things, others I/O, or it may make calls to Google Maps API and the Google Calendars API and so on. Then you have a set of pure logic, and this is fairly complex pure logic that figures out the best times and the best locations and so on. And then you have the HTTP response to the client, whoever calls the service. And all the database updates related to this, like updating the emails and updating the meeting, et cetera, are done on the client side and not on this specific service, right? So this is slightly different from a typical web service that you see, and it's slightly different from how we initially started off. So when we initially started off, we did a lot of intermingling between the business logic and the microservice calls. But we found it very, very difficult to test, just practically speaking. The tests ran very slowly. It was difficult to define tests and so on. So we made a conscious effort over a span of a few months, but it has been consistent over the last 2 years, where we kept the pure business logic separate and the I/O call separate. So in code, this is what it looks like. You have a function decide, which is the actual decision-making system, which takes in an email thread, which can contain emails from humans, but it also contains outgoing responses from Amy and Andrew. And the output of this decide is basically the outgoing emails. What are the emails we send out people? Then we have a tiny function, tiny I/O function, which has limited business logic, which does all the queries. And then we have this decide pure, which is a pure function. There are no side effects. There is no mutation. There is no I/O calls whatsoever. And this is easily testable. And we use logging, and we use Ammonite for debugging to make this easily debuggable. And then we have this meeting context, which is basically the output of the fetch data and the input to this decide pure thing. And the decide pure itself returns an updated version of the meeting context, which can be the updated emails or the updated meeting, the updated profiles. For example, they may have set a specific preference. So this is what the meeting context is. So what we do here is we take a snapshot of this meeting context. So what this means is, like, whatever the output of this fetch thing, we convert it to JSON, we assign a unique ID, and we just store that in the database.
So if any of you use like APM tools or something like that, like New Relic in production, you'll get a sort of vague version of this. You'll drill 8 million lines down into some crazy UI, and there'll be method call, and then you'll click on something, and it'll show you some enormous whatever it was able to capture. But the nice thing is, like, if you write code like this, you don't have to rely on some incredibly complicated tool with an impenetrable UI and no API to find this kind of information. Like, you get it, you save it, you do whatever what you want with it, and Varun will tell us what we do with it.
So just think about it. So we have this exact thing that went into this very complex decide pure function, right? And that we have found to be fairly powerful for debugging and various other things. Some specifics, this has been very useful for technical teams as well as our customer success teams. So whenever they see a bug, for example, the 1 a.m. bug, all they have to do is they have to click a button. They get a snapshot that is stored in the database, and they give us an ID. So in the bug report, they'll give a description of what went wrong and a snapshot ID. And for us, like our developers, all you have to do is take the snapshot ID and hit a command like decide snapshot ID, and we can trivially reproduce it. So our iteration cycle for at least reproducing bugs has been very, very fast because of this. I want to give a special shout out to Ammonite, which I've been using quite a lot, and specifically the debug thing where you can pause the execution and you can analyze the variables and perform functions on those variables.
And again, I mean, this idea of storing context is obviously not unique and new. Like, there's a bunch of languages that support Smalltalk or something. You can actually freeze the entire execution context of a given thread when it crashes, and you get the whole stack frame and all this kind of stuff. And point is, that's very hard to do, also very hard to reload, to warm up again, to then work on. With this kind of approach, you don't have to do any of that. I think that's the kind of nice thing. You're back to working with, it's a Scala object, and it's a bunch of JSON. I can look at it in the database. Just the tooling to manage this stuff is so much more powerful than the very specific kind of debugger, low-level stuff that you would need if you wanted to resurrect a particular function call in an arbitrary environment.
Getting back to the thing where you have tests for the things that you know that you shouldn't change, you should change or should not change, but for the other side, the unknown stuff, right? The approach we have used for many of our systems is basically replace, which builds upon the idea of snapshots. So over time, you store snapshots for every single request that goes into the system, right? And over time, you get a huge, huge database of snapshot. It's, funnily enough, it's actually one of our biggest data sets in our system right now. But once you have this huge set of snapshots, whenever you make a change, you replay these. So you take a subset of them, you pass it against what you are developing on, the branch that you're developing on, and what is currently running on production, and just compare the two results. You perform a diff of the two results. If they are both exactly the same, that means this particular snapshot was not affected. And if there was a difference, you can analyze the difference and see, OK, has something changed? Is this change expected? If so, fine. If this change is not expected, and that happens quite a bit when you're developing, then you analyze it. You see if you have to make a change in your code or not.
And I think there's two important things here. I mean, this is like shadow mode, if any of you've done like A/B kind of testing. This is like running in shadow mode. But shadow mode is actually very hard to operationalize, to actually make happen. And the architecture that Varun was showing is critical to this because A, shadow mode requires inputs. Like you have to actually get the inputs to the system. And then you do things like queue splitting and HTTP traffic splitting and weirdness around doubling your database like capacity so you can handle two systems calling it at the same time. That all goes away largely with this because you just you make the same call, load the same snapshot, not a big deal. And the other bit is you have to make sure that the one shadow system is not sending out every email twice. So you have to make it sort of idempotent or at least not damaging. And if you remember back to the architecture that Varun was showing, because the output of this is just a response object, it's up to the client to decide to persist it or do something like that, you get the kind of no side effecting part for free. So basically all you end up having to do, quote unquote all, is compare the responses from two different services.
Practice, this is what it looks like. So we have built a fair amount of tooling in this, simply because we tried it out, and Chris was actually instrumental in all of this. But we have built a lot of tooling around making it easy to go through the snapshots and see if something went wrong. And so for every commit or every pull request that you have, we get a summary saying, hey, there were so many matches, there were so many diffs, and here's a report for you to analyze. And if there's a diff, we have built tooling to make it easy to analyze diffs instead of just showing a left-hand side and right-hand side and huge JSON blobs, which is like probably 1,000 lines long. We just show the specific fields that have changed. Again, this makes it very, very fast. So if you think about it, so if there are 200 things that have changed, chances are that 100 of them will look very, very similar. So after looking at, say, 10 specific instances of that diff, you can just skip over most of them.
The dots in that screenshot are not for the benefit of the slide. That's actually what it looks like.
So here's the library associated with it. You can take a look at it, and it's contribute to it. That's great. Or use it. That's even better. So is this doable in this practice, or is this very, very x.ai specific, right? So it's been very useful for us, at least for this part of the system. Can we expand it to other systems in x.ai? Can probably some of you use this? And I think that's a good question to be asked.
So I think from the coding pattern perspective, I think yes, absolutely. I mean, we use this stuff in production. What are the questions that normally come up, right? Is this going to sort of hinder us somehow? Are we going to lose some kind of expressivity that we might need? I think that's where the lesson about trapdoors comes in, like the example Varun was giving in the test data specifically. If you then go and make your actual domain object constructor private or something like that, or not importable, then you are tying yourself. Like, we found that you do still need to have that trapdoor. If you want to get the string out of a type wrapper, you need to make that easy. Like, you don't want to have to go through all kinds of hoops and say, no, thou shalt never use the string inside a type wrapper kind of thing. For performance reasons, you don't want to be creating millions and millions of objects. Like, the garbage collector doesn't love that if you're basically wrapping a string in an object every time. If you're familiar with them, you probably know the obvious things to try for this are things like inline and anyval. If not, I highly recommend you have a look at the SIP for value classes. That's what the anyval thing is. If you extend anyval, that's a bit of magic that tells the compiler that it should actually not bother creating new objects for the thing. It's just duct taping new methods onto stuff. And sorry, I did say the easy breakout when necessary.
From the architecture side, I think it sort of depends. So there are many applications which are all about I/O, right? I've worked in applications where there was very, very little business logic. The difficult part was all about making the database queries fast and optimizing the indexes and stuff like that. And So it may not be applicable, the architecture which I spoke about may not be applicable for those kind of systems. And here, obviously, you need to query more data than you need. So by separating I/O and the business logic completely, you're not going to explore all the code parts in the business logic, which means you don't need all the data that you just queried, right? But so you need to make a decision whether it's OK to query more data than you need, than you actually need. And in some applications, that's fine. For example, in our application, it's turned out to be not a problem so far. But it may be a problem in many cases, and that's fine. And then you may have some systems where you perform a significant business logic. You do I/O based on the results of the business logic. Then you have another significant business logic. Obviously, this does not work in such a case, but it might work with such a modification. And this is something we have systems in our company where it's like that, and I am currently exploring how we can modify it to make it work. So the way I'm thinking about it, you split it up into pairs of I/O, and then business logic, I/O business logic, and you perform snapshots on these independent parts. Again, I've not tried it yet, and I don't know how well it'll work in practice, but that's what I'm thinking of implementing. Practically speaking, we have 100K lines of code where we have implemented this architecture with a snapshot and so on. So it has worked for us for a significant amount of time for a significantly large code base. The obvious caveat is like, what does lines of code even mean? But it's kind of worked for us. On a higher level, I think the lesson to be learned is that the separation of I/O and business logic, we all know that it's pretty good software practice. It's a pretty good design decision to make, but it is a very fundamental thing that can lead to very interesting testability practices and testability properties, and like snapshots, debugging, just easy test data, and so on. So I think these are good reasons why you should do this. And x.ai, it's definitely worth it. And we have regressions over here have become quite rare. So yeah, that's about that. These are some of the libraries, another summary of the libraries that we spoke about over here. And we have a bunch of other open source stuff, other open source libraries. Do feel free to check them out and use them.
Just because it's like incredibly cool in your dependency set to have AI.x. It's a great way to start it. Like, makes it look awesome, I can tell you that. Yeah, we get a bit. No. So contact details, we amazingly managed to get through it in exactly the time we had planned. That's like unbelievable. No regressions on that front. If you have any questions for us after the session, here's our contact details. The slides will be up. You can tweet at Varun or at x.ai. If you're interested in what we're doing, yeah, we always have positions for developers. Come see us. Come speak to Chris. Anyone else? Quick shout out on that front. It's more x.ai at Scala Days. We kind of been given our own track. That's pretty cool. Chris is going to be talking twice today at 4:50 and at 6. So go catch his talks. And yes, remember to rate the session. Question time. Thank you very much.
Cool. Thank you.
Sir. How do we enforce usage of the type wrappers, or safe wrappers? Well, I think part of it is, we can do some linting. Part of it is education, I think. I mean, it's one of those trade-offs where we hope we are still at the level of size and scale of a company where just knowing that these things exist means that people will do the right thing. I mean, it's not a sort of defense in-depth problem where we're actively trying to prevent against people being sloppy. Like, we're very lucky we work with a bunch of very smart and motivated people. So it's once you tell them that they have these tools. And of course, also what happens, I mean, we've learned especially when you get people working on a code base who are not familiar with it, what they tend to do is they try to, as best they can, imitate the style of the code they already see. So if you see a triple equals in the line of code that you've just copy-pasted, more likely than not, that's what you're going to use, as opposed to saying, this doesn't make any sense. I'm going to use something else.
No, that's exactly what happened over here, actually. It's a combination of looking at pull requests, and just if some of the more sort of senior Scala engineers or knowledgeable Scala engineers do this, people who are just getting into Scala tend to ask, hey, why do you do this? That's a good idea. Let me also do this in my code. So that's what tends to happen.
So question was, have we seen any resistance to the use of type wrappers? And then have we had any performance impact from that? I know Chris can probably talk potentially about performance impact. It's not the bottleneck of our system right now. So, I mean, to that extent, it may, once we magically optimize everything else, it may turn out that that's where we have an issue. But at the moment, it's not the part where we're struggling, or if we are struggling, that's not the bottleneck that we're looking at. And yeah, I think resistance, I think is a similar answer to the previous question. We're in the lucky position where we're not trying to fight entrenched like mentalities of the kind of, why should I bother doing this? It doesn't make any sense. Like, this is a stupid idea. We're lucky that we work with a bunch of people who are very receptive to ideas, as long as we can make them available and present them, and then obviously justify them. No, you can't do the thou shalt, it has to be thou shalt because. And as Varun said, most of this wasn't like upfront design. It's not as though we sort of went into a room and sat down and went like, how do we design the perfectly safe? No, it's like after a production incident or after some lessons, some sort of postmortems, is that you say, okay, we've had too many issues with this kind of stuff. Like, how do we go about it? This is sort of the three, I don't know if anybody knows the three-arm sweater meme. Like, celebrate failure. Once you can do that, once you stop trying to assign blame, you can come up with ideas like this, and we get good buy-in. But we're lucky in that sense. I don't know. Resistance? No?
No. I mean, yeah. As long as you are able to justify it and explain it and educate people and actually make it easy, right, to do it, it's generally accepted.
All right. Oh, over there. Chris, question? Speaking to the mic, because otherwise it won't appear on the recording.
Hey, so one thing, I mean, for performance, the value classes give you some benefit there. Not completely without complication, but it solves a lot of problems. But for then another thing with type wrappers is that there are different areas where you can use them. For identifiers, for example, it's fairly painless because you're only doing equality comparison, and that's something you can just make work on your wrappers equally, and then it's fine. It's much harder when you have types where you, like when you wrap a string that you actually want to modify, and then you would have to have the, like, interoperate with the thing inside of it, so we're actually not doing that. We're using it for identifiers, and we're using it for strings which we don't modify. And when we do, which at least we don't transform, but sometimes we need them somewhere else, then we get the string out and use the string and embed it into something else. But we don't like do operations on them. That makes it painless.
Which a broader theme is like immutability of certain types of data, blah, blah, blah. That kind of plays into that. There was another question. Yes, sir. The question was, were we concerned by the redundant I/O that we were doing?
I think it sort of comes down to what the trade-offs are, right? So in our particular system, there are a couple of interesting things. We're doing a real-time system where you'll have to have like sub 10 millisecond response or sub 100 millisecond response. It's sort of expected that Amy is going to take a few minutes to respond, and that's this thing. So performance is not a concern. And in general, like with sort of the AWS and things like that, and we don't have hundreds of thousands of requests or tens of thousands of requests going to this system yet, to the point where we are getting bottleneck on the system resources, on the memory resources in particular. To us, the trade-off of that trade-off versus the idea of having this one thing where you can just easily write tests against was just too good. It was just too good. And so it's not good for everybody, but I think it is very, very important, useful for us to do this.
Yeah, I think Varun tried to touch on it a bit in the slides. It's the question of whether you can do this is heavily dependent on the type of I/O you do. Like we were discussing over breakfast, the magic example where imagine like for some crazy part of your business logic, you need to get all the friends in your network and then the friends of those friends and then the friends of those friends, and then for every call you're loading the entire database into memory. Like that's clearly not a situation that supports. There's an interesting angle in the sense that that's also a bit of a smell. Right? To some extent, the amount of I/O you have to do here also tells you a bit about what craziness is happening in your code paths. So it sort of surfaces potentially a problem with your application in general. But yeah, it's not, I mean, and I think that's what Varun was also talking about. If you see that you have a specific point where one code path might go off and have to do a huge amount of stuff, then you might consider wrapping, the bit above that in one of these constructs. I mean, for me, the big lesson was like I've grown up like writing lots of code, which is get input in, and then person DAO dot save blah somewhere in the middle of my function. And the idea that instead of doing person DAO.save blind my function and have to mock it out and do all that kind of stuff, to say, well, the output object of this function will be a list of people to save, and then you can delegate that problem to somebody else, is a huge benefit in terms of keeping your business logic pure and making it more testable, because then instead of having to say like, oh, did my mock get called with the expected things, blah, I just inspect an output value. It's similar to some sort of CQRS style ideas in terms of making commands visible, and those of you who've been fortunate or unfortunate enough to listen to a free monad talk, something like that, will see similar kind of ideas in that once the commands that you're trying to do, the output that you expect, becomes just objects that you return from your function, you can do all kinds of interesting things with those and don't have to like peel them out of the back end of a database to do something.
Yes. With the safe equals and the safe contains, like I'm pretty sure those are just like warnings and like something like IntelliJ, maybe other IDs. What made you choose to like kind of build your own wrappers that produce like errors instead of just relying on warnings? Were people ignoring warnings?
Excellent question. So yes, there's a couple of answers here. One is you need to use those IDEs. We have a very broad range of usage of systems. I think at least half of our Scala developers use some combination of a text editor and the REPL or the compiler directly. So difference in that. Yes, warnings. So you know, I always say in this sort of, we all have those guidelines. You try to use fatal warnings. Try to avoid any warnings from ever appearing in your code base. And I think by and large we're pretty good about that. But yeah, I think warnings are a very blunt instrument, easily ignored on the one hand. If you make them all fatal, like it can impede your speed quite a lot. I think there's definitely stuff you can do in terms of tuning. I think that go on, Varun.
I want to add something to that. So fundamentally, warnings, you're not going to be caught by your build system, right? So we do want cases like this to fail compilation as much as possible. But on the other hand, like as Andrew spoke about it, you don't want to make it too tedious to implement. And these are actually not too tedious to implement. You can implement it, and you can just try and educate people to use it everywhere. But once you do that, you just replace replace contains with safe contains, right? And that's very easy to do for a potentially big benefit that you get. And that it is caused by build system. It's caught by the build system, and it's not pushed to production.
And I think another point is the warning you actually get is inferred any, right? The compiler doesn't actually. It can't. Like it's supposed totally legitimate for you to try to do all these operations. There's nothing wrong with them intrinsically. The warning sign is that in order to make those operations possible, the compiler typically has to infer a very, very basic type. And that's the kind of thing that you can get warned on. But depending on how your type hierarchy is structured, you might not have to go all the way to any to make a bad comparison. Like, you know, you've got the list of tigers and you want to check whether a penguin is in there. And if they're both animals, then you're not going to get a warning, because it's a totally legitimate thing to do in that particular business context. I mean, I think the thing that we've leveraged this for is also to encode what we mean in terms of legitimate equalities within the context of our domain, which a compiler warning will never be able to give you because it doesn't know anything about your domain. So I don't think it's fair to expect it to do that. All right. I think we're done. Thank you very much.